Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video describes the empirical rule, Chebyshevs Theorem, and how to use them. Let's get started. In the previous mini-lecture, we met the cousin of standard deviation called variance. Now we're going to meet the cousin of the range rule of thumb called the empirical rule. If we have data that are normally distributed, or even just approximately normally distributed, then about 68% of the data values will be within one standard deviation of the mean. About 95% of the data will be within two standard deviations of the mean, and about 99.7% of the values will be within three standard deviations of the mean. Now, let's go back to our chocolate chip cookie example, because hey, who can get enough of chocolate chip cookies, right? Let's see how to apply the empirical rule to that data set. The empirical rule says 68% of the values in that data set are going to lie within one standard deviation of the mean. So here's what we get when we put numbers to that. Okay, we saw previously that our mean value is 23.4 and the standard deviation is 1.7. So we subtract 1.7 from 23.4 to get a minimum value of 21.7. We add 1.7 to 23.4 to get the maximum value of 25.1. Now, how many values in our data set should be between 21.7 and 25.1? Well, we had 5 cookies in our sample. 68% of 5 is 3.4. Since we don't count partial cookies, we're going to round that up to 4. Do we have 4 values in our data set that are between 21.7 and 25.4? Well, here's our data set of chocolate chip counts from our sample of 5 cookies. And indeed we see that 4 of the 5 values reside between the bounds predicted by the empirical rule. Let's see how the rest of the empirical rule plays out. It says that 95% of the data should be within 2 standard deviations of the mean. That means 95% of the data should be between 20.0 and 26.8. 95% of 5 cookies is 4.75. We again round up to the next whole number. So 5 means all of our data points should be within 2 standard deviations of the mean. Is that what we see? Well, check this out. Yes, every one of these data values is between 20.0 and 26.8. Shouldn't be any surprise then that 99.7% of our data will be within 3 standard deviations, as the empirical rule predicts. 99.7% of our data will be all 5 of our data points, and yes, they are all between 18.3 and 28.5, just as the empirical rule predicts. So, for normally distributed data, the empirical rule can be very useful in predicting minimum and maximum values that reside within 1 to 3 standard deviations of the mean. Okay, I'm not up on my Russian here, so I'm probably going to slaughter this dude's name, but I'll give it a go anyway. There was this mathematician, Russian mathematician, back in the 19th century named Chebyshevs. And now I'm sure there's some Russian out there yelling, "Stupid American, stop slaughtering my language." Well, I'm sorry, I don't speak a word of Russian. Well, actually, I do know one word because I grew up during the last legs of the Cold War. There's this Russian word, glasnost, or something like that. It meant opening up in friendship sort of thing. I might know more words, but I really haven't thought much about it. It's like they say, what do you call someone who speaks 3 languages? Trilingual. What do you call someone who speaks 2 languages? Bilingual. What do you call someone who speaks only 1 language? An American. I told that joke once to a French Canadian, and he laughed his head off. Anywho, let's get back to this Chebyshev dude. Chebyshev wanted to take the usefulness of the empirical rule and extend it to any distribution, not just those that are normally distributed. So he put his brain to the task and derived what has become known as Chebyshevs Theorem. It tells the minimum proportion or fraction of a data set that will be within k standard deviations of the mean value, where k is any number greater than 1. So if we set k equal to 2, Chebyshevs theorem predicts that at least 75% of the data will reside within 2 standard deviations of the mean. This compares well with the empirical rule, which says that for normal distributions, 95% of the data lies within 2 standard deviations of the mean. 95% is greater than 75%, so this works. If we set k equal to 3, Chebyshevs theorem predicts that at least 89% of the data will reside within 3 standard deviations of the mean. This again compares well with the empirical rule, which says that for normal distributions, 99.7% of the data lies within 3 standard deviations of the mean. 99.7% is greater than 89%, so again, it works. The beauty of Chebyshevs theorem is that it applies to any distribution, whereas the empirical rule applies only to normal distributions. That's why the proportions predicted are minimums. Using at least lets you apply the prediction across the board to any distribution. Now here's a table of predicted proportions based on selected values of k. When working problems with Chebyshevs theorem, you just need to memorize the values, unless of course you get a kick out of memorizing the equation and using that. I would think though that for most problems, especially those in my math lab, if you just memorize the proportion predictions for 2 and 3 standard deviations, you should be okay. Let's look at an example involving M&Ms to practice what we've learned so far. Some of my past students helped me gather data on M&Ms by opening so-called fun size packages and counting how many M&Ms of each color were inside. These little packs are, of course, not the real fun size. I mean, get real, man. There's nothing fun about just a little chocolate. You need a package the size of the bag that the little packs come in. That's the real fun size. Anywho, you can find the data we collected in the M&Ms file in our StatCrunch group. Please pause the video now, go open that file in StatCrunch. You'll need that for this activity. Okay, here's our first question. Using the empirical rule, what is the percentage of green M&Ms that are within 1 standard deviation of the mean value? You don't need StatCrunch for this, just a good memory of the empirical rule. So, what say you? I'll give you a few seconds. Well, I hope you said 68%. You really need to memorize the percentages in the empirical rule because it makes answering questions like this, which you could see again, really easy. Here's the next question. Using the empirical rule, what is the percentage of red M&Ms that are within 3 standard deviations of the mean value? Again, I'll give you a few seconds. Well, I hope you said 99.7%. If not, go make some flashcards and get busy memorizing. Okay, what would 5 green M&Ms in a package be? Would that be a usual value or not? And if not, is the value significantly low or significantly high? Again, I'll give you a moment. Okay, here you want to use the range rule of thumb because you're asked about usual values. So when you calculate your minimum and maximum usual values, you see that 5 is inside those bounds. That means 5 is a usual value. It's not surprising to see that number in the data set for the green M&Ms. Now, using Chebyshevs theorem, what is the percentage of yellow M&Ms that are within 3 standard deviations of the mean value? Well, I hope you said 75%. If not, it's flashcard time. Note the color here doesn't matter. The particular data set does not matter. Chebyshevs theorem applies to any distribution, so just memorize the predictions and you should be good. Okay, last one here. Using Chebyshevs theorem, what's the percentage of yellow M&Ms that are within 3 standard deviations of the mean value? Well, I hope you said something like 88.89%. This is actually a good value to memorize because you're not likely to get asked for more than 2 decimal places. Of course, if you're concerned, you will be. Just memorize 8/9 and convert to percent form for how many decimal places you need. And that brings us to the end of this mini lecture. I hope you found it helpful. Thanks for watching. I'll see you in the next mini lecture.